This video is going to be on completing the square once again, which is why it's called Completing the Square Part 2, except this time we are going to be breaking one of the rules we talked about in the first video. And if you are watching this video but haven't watched the first video, I highly recommend that you do so that you understand the methods that I'm going to be using and know what I'm talking about. So, without further ado, let's get into Completing the Square Part 2. In Part 1, we talked about two requirements to be able to use completing the square. We said how A had to be 1 and B had to be even. And that was true. That would be the easiest possible way to use completing the square. But in this video, we are going to be breaking that first rule where A has to be 1, and we're going to have A be other numbers. The reason why I didn't do this in the first video and why I was considering not making this video is because it's a little more complicated, and usually if it gets to this point of being complicated, you might just want to use the quadratic formula. But we're going to give it a try, so let's get to an example problem. So for this example, we have 5x squared plus 40x minus 45 equals 0. You can see already that my A term is not 1. My E term is 5, but my B term is still even, which is good. Now, there's a couple different ways we can approach this, and what we really need to make sure if we're going to be having an A that isn't 1 is that A is a factor of B, because we are going to have to do some factoring, pulling out a greatest common factor, at the very least between A and B. And if we can't just do that, if we can also do C, that's great. But if we can't, I'll show an example of how we can handle it if we can only pull a factor out of A and B instead of A, B, and C. So with that said, all three terms, A, B, and C, have a factor of 5 that I can pull out. So that's what I'm going to do. I've got 5 times the quantity x squared plus 8x minus 9 equals 0. So I have pulled a factor of 5 out of each term, and now I have my original rules being met. A is 1, and B is even. If you factor out something and B is no longer even, probably not going to want to use the completing the square method. But now that that's been done, there's a couple different ways you can approach this, but I think the easiest way is to first get rid of this 5. So how are we going to do that? Well, we're going to divide both sides by 5. So 5 divided by 5 cancels itself out, it's just 1. 0 divided by 5 is still 0. So it's a nice little trick to get rid of that coefficient in front of the quantity, and it's not going to play any part in changing our answer. So now that that's happened, what do we have? Oops, we've got x squared plus 8x minus 9 equals 0. And this looks just like a problem from video 1. We're going to be using the same techniques. So I have a b that is even, it's 8. So, just like before, take 8, divide it by 2, square it, and that's going to give us 4 squared, which is 16. And now we can place it into our equation so that we get a perfect trinomial just like we wanted. So let me scoot this up a little. We'll get x squared plus 8x plus 16, and then we can't forget about the minus 9, and then the minus 16 to equal 0. Have to have the minus 16 because we added 16 into it, so this keeps it balanced. And now I can do my factoring on my perfect trinomial. Take the square root of x squared to get just x. Take the square root of 16 to get just 4. Put parentheses around it. Look at the sign on B. It is positive, so we're going to have x plus 4 quantity squared. And then minus 9 minus 16, well, that just gives us a minus 25 equals 0. And now we can go about the final steps, which is getting that x all by itself. And you're probably thinking at this point, excuse me, you're probably thinking, hey, this is going on kind of long. And you're right, it's a long process. But as I said in the first video, some people prefer completing the square to using the quadratic formula. There's less to memorize. And if you really enjoy algebra, well, this might be the process for you. So we need to move our negative 25 over to the other side. So we'll add 25 to both sides. And I'm going to start writing over here because I'm running out of room. I get, just block that off there, x plus 4 quantity squared equals positive 25. Take our square root, and since 25 is a perfect square, that's why I started off with this problem, this becomes plus or minus 5. So I have x plus 4 equals plus or minus 5. And then let me draw this all the way up here. Sorry about running out of room. When I take 4 away from both sides to get x all by its lonesome, I get x equals negative 4 plus or minus 5. And all I have here are integers, so I might as well do my addition and subtraction. And in the end, we get x equals negative 4 plus 5, which is positive 1, and x equals negative 4 minus 5, which is negative 9. And there we go. There's our two answers. And we started off with something that originally broke our rules. Okay, let's try another one. So for our second example, you notice once again A is not 1. B is still even, that's good. And the probably most important criteria for if A is not 1 is that A and B, at the very least, are factors of each other. 3 is a factor of 12. But what you might notice is I don't have a factor of 3, or technically 1 is a factor of 3, but I can't pull a group of 3 out of this 1. So this is going to change how I have to approach this problem. I won't be able to do some of the nice little tricks I did before, but that doesn't mean it's not solvable. So let's get started by factoring out the greatest common factor between 3 and 12, which, if for right now, is just going to be 3. So I factor that out. I take 3, and it's x squared plus 12x. Whoops, not 12x. 4x. And I have to close the parentheses there because I didn't do anything to this. This is still plus 1 equals 0. I can't do my little division trick with the 3 this time because I didn't take it out of everything. That's going to change this, and I don't want that to be a fraction right now. So I'm going to take my b, which is 4, and what can I do with it? I can use my little equation from before. I'm going to do it off to the side over here. So we've got 4 divided by 2, quantity squared, which is the same thing as 2 squared, which is the same thing as 4. Alright, so what does that give me? That gives me my original 3 times x squared plus 4x, and since this is where our perfect trinomial is going to be, the 4 that I got over here is going to go inside here, so plus 4. I still have my 1 from before, but this is where it's different. This is where you have to be real careful about what you're doing. I put a 4 in here, but this 4 is actually being multiplied by this 3 eventually. So I didn't actually add 4, I added to the equation 3 times 4, which is 12. So with the 1, I have to subtract 12. Let me say that again. When I used my completing the square method and I got 4, I put it into this quantity. This quantity, as a whole now, is a perfect trinomial, but it's being multiplied by 3. So since I'm not just adding a 4, I'm adding 3 times 4, I have to subtract 3 times 4, which is 12. And that is equal to 0. Now I can continue on with the method as before. The 3 is going to stay on the outside. I can simplify this down into a perfect square trinomial or binomial, which becomes x plus 2 quantity squared. I take care of my 1 minus 12, which is negative 11, equals 0. And from here, it's really the same as the first video, trying to get the x all alone, with one extra step when we have to divide to get rid of the 3. So let's give that a try. We'll start off by adding 11 to both sides. Cancels the 11s out. Move this up. And now I have 3 times x plus 2 quantity squared equals 11. You might be wondering, well, what am I going to do next? Am I going to get rid of the 3, or am I going to get rid of the square root? And when we're solving these, we go in opposite order of our order operations. So I got to get rid of that 3 first, so I'm going to divide everything by 3. And we see a good friend, Mr. Fraction. If you don't like fractions, it's okay, don't worry about it, but you're going to have it in this problem, and that's going to happen sometimes. That's life. Deal with it. So I've divided by 3. I now have just the quantity x plus 2, quantity squared, equals the fraction 11/3. Now I can get rid of my exponent using the square root symbol. So I'm going to take the square root of the fraction, and since this is a fraction, we're not going to bother trying to change it around right now. We're going to leave it as it is. This cancels out our square, and we move it up a little bit more. I now have the quantity x plus 2 equals plus or minus the square root of 11/3. Last step, get rid of our plus 2 by subtraction, and we end up with x equals negative 2 plus or minus the square root of 11/3. Now there will be some people who say we shouldn't leave it like this, and generally I am one of them, but this video has gone on long enough, and hopefully you get the basic idea of how to use completing the square when working with a quadratic equation that does not start with 1. Good luck with your example problems, and hope this video helps.